A gasoline engine has a thermal efficiency of 25%. If heat is expelled from the engine at a rate of 1.50 times 10 to the power of 6 joule per hour, how long does the engine take to perform a task that requires an amount of work of 3.0 times 10 to the power of 6 joule? A gasoline engine is a heat engine and its thermal efficiency is 25%. So we'll use the eta to represent the thermal efficiencies of this gasoline engine. It is equal to 25%. Heat is expelled from the engine. So this is QC. QC is the heat that flow from the substance in the engines to the low temperature reservoir. And in these questions, it says that in every hours, the quantities of heat that flow from the substance in the engines to the low temperature reservoir is 1.50 times 10 to the power of 6 joule. So that means the power of the heat flow to the low temperature reservoir from the substance in the engine is equal to 1.5 times 10 to the power of 6 joule per hour. This is a power concept. Now the question asks, how long does the engine takes to perform a task that requires an amount of work of 3 times 10 to the power of 6 joule? The total work that we want to produce from the gasoline engine is this one, 3.0 times 10 to the power of 6 joule. But the question asks, with this heat engine, how long? That means how many seconds or how many hours it is required for the engine to produce these quantities of the output work. So what we need to do is that we find the power of the output. From the power of the output and with this known quantity, then we can find out what is the time required to produce this amount of the output work. We list out first the informations that we can get from the questions and which we will use to solve the problems later. The first one is the efficiencies of the gasoline engine, which is 25%, eta equal to 25%. And the second is the amount of the heat that flow to the low temperature reservoir in every hour, which is 1.5 times 10 to the power of 6 joule per hour. We start to solve the problem by using the definitions of the thermal efficiencies of heat engine, which is eta equal to output work divided by the QH, where the QH is the heat absorbed by the substance in the engine that will perform the cyclic process. Since we have the informations about the PC and we do not have the informations about the QH, then now the next step, we try to express the QH in terms of the output work and the QC. So QH is equal to the output work plus the QC. We divide the numerator by the T and also divide every terms in the denominator by the times T. So now we have these expressions. And we can write everything now in terms of the power. So now eta, the thermal efficiencies of the engine, is equal to the output power divided by the summations of the output power plus the power of the heat flow to the low temperature reservoir. But what we want to find is the P output power. Therefore, we change this output power as a subject of the equations. We'll obtain this. Output power equal to eta divided by 1 minus eta multiplied with the PC. Eta thermal efficiencies of the heat engine is 25%. So we will substitute by 0.25, and this one, the denominator is 1 minus 0.25, and the PC is 1.50 times 10 to the power of 6. So our answer would be 5 times 10 to the power of 5 joule per hour. The unit is in joule per hour, not in joule per second, because the value that we substitute for the PC is in joule per hour. That's why we have joule per hour. This part, there is no unit. It is the ratios of the eta, therefore no unit. So the final unit for this output power is joule per hour. We want to find how long the engines needs to take to produce this amount of the output work. So with this information that we obtain for the P output, now we can find the T, the time, by using the output work divided by the power of the output. We substitute the work done by 3.0 times 10 to the power of 6 divided by the output power, which is 5 times 10 to the power of 5 joule per hour. We'll get the answer is 6.0 hour. So this is the times required for these gasoline engines with the thermal efficiency 25% to produce this amount of the work done. It needs to take 6 hours to produce this quantity of work done.